Imagine shaving hours off debugging time, transforming tangled legacy callbacks into sleek, readable, and maintainable code, simply by mastering one key JavaScript feature. If you're building or maintaining modern front-end apps, your code likely processes lists of data, fetching items from APIs, transforming collections, or updating UI in response to user actions. But legacy callback patterns can leave your codebase cluttered, hard to follow, and prone to bugs. Today, you'll discover how JavaScript arrow functions can revolutionize the way you handle asynchronous list processing. In this tutorial, you'll learn how to refactor verbose, deeply nested callback code into clean modern patterns using arrow functions, promises, and async await. You'll see how this not only improves readability and maintainability, but also aligns your code with the latest best practices in frameworks like React, Vue, and Angular. We'll break down the core syntax differences, walk through real-world refactoring examples, and show you how to avoid common pitfalls, empowering you to write more robust, scalable, and future-proof JavaScript. Stop letting legacy patterns slow you down. Unlock cleaner, smarter asynchronous code today. Subscribe now to stay ahead with deep dive tutorials and hands-on guides that keep your skills sharp and your projects competitive. Arrow functions in JavaScript are a transformative evolution in how developers express logic, especially when handling asynchronous operations like list processing. To understand their significance, imagine writing a to-do list. With traditional functions, each task requires you to write out all the steps explicitly, even repeating your name every time you assign yourself a chore. Arrow functions act like shorthand notes, clear, direct, and without redundant context. For example, consider the difference between function item, do something item, and item, do something item. The latter is not just shorter, it visually aligns the intent of the operation with the data, making the flow of logic immediately apparent. This clarity is especially powerful when processing lists, such as fetching user profiles from an API or transforming arrays of data. Instead of verbose, nested callbacks that resemble a labyrinth, arrow functions enable a linear, readable chain of transformations. They also inherently adopt the surrounding this context, eliminating one of the most error-prone aspects of legacy JavaScript. In practical terms, this means that asynchronous operations, like mapping over a list to fetch resources, can be written in a style that mirrors synchronous logic, reducing cognitive overhead. Arrow functions thus serve as the linguistic upgrade for JavaScript's functional and asynchronous capabilities, bridging the gap between expressive intent and executable code. Legacy callback patterns in JavaScript often led to what developers call callback hell, a situation where nested anonymous functions made code tangled and difficult to reason about. Imagine a relay race where every runner needs to be explicitly told who the next runner is, what baton to pass, and how to handle any mishap along the way. Each level of nesting increases the chance of mistakes and confusion. Arrow functions combined with modern asynchronous constructs like promises and async await refactor this chaotic scenario into a well-organized, clearly marked track. When processing lists asynchronously, such as making a network request for every item in an array, arrow functions, together with array methods like map and for each, allow developers to flatten deeply nested logic into readable sequences. For example, using ids.map edcree fetch user data ID within a promise, all harnesses the power of parallel execution without sacrificing readability. This approach not only reduces boilerplate but also centralizes error handling, making it easier to maintain and debug. Arrow functions thus act as both a scalpel and a shield. They slice away unnecessary syntax and protect against the proliferation of confusing callback structures. In the context of modern front-end apps, where real-time data and asynchronous flows are the norm, adopting arrow functions as part of a refactoring toolkit is essential for writing robust, maintainable, and future-proof code. This file demonstrates the core of refactored asynchronous list processing using JavaScript arrow functions, promises, and async await. User IDs are fetched, a batch API call is performed in parallel for each ID, and the user data is processed by a concise arrow callback. Error handling is integrated with try-catch, and the code avoids callback nesting for improved readability. This utility file provides a reusable delay function using an arrow function and promises. Such utilities are often used for testing or throttling asynchronous operations in list processing pipelines. The configuration file defines the project metadata, dependencies, and scripts for running, linting, and testing the code. It ensures the environment supports ES modules and modern JavaScript, and includes linters and test runners that help enforce arrow function usage and code quality. The application interface loads, displaying the main heading, Arrow Functions, Asynchronous List Processing. The viewer has time to read the header and accompanying description, establishing the topic of modernizing asynchronous JavaScript list processing using arrow functions. The navigation bar at the top of the app draws attention, with each navigation button highlighted in turn. First, legacy callback pattern, then refactored with arrow functions, and finally, advanced patterns and error handling. This showcases the available sections for exploring different implementation styles and advanced techniques. Returning to the refactored with arrow functions section, the demonstration focuses on the default modern approach. The main content area is brought into view. The Load Users Modern button is clicked, initiating an asynchronous data fetching operation. While the users are being loaded, a visual indicator communicates the loading state. Soon after, a list of users appears, confirming that the refactored arrow function-based approach has successfully processed the list asynchronously. The demonstration scrolls down to reveal the code example labeled Refactored Code Example. This code block presents the streamlined, readable implementation using arrow functions and modern async patterns. The viewer has time to observe both the functioning UI and the associated code, reinforcing the connection between concise syntax and real-world results. Next, attention shifts to the Legacy Callback Pattern section. After selecting this section from the navigation, the Load Users Legacy button is clicked to trigger the older, callback-based implementation. As before, a loading indicator appears while users are fetched. When the data loads, the legacy processed user list is displayed, allowing viewers to directly compare the outcome with the modern approach. The demonstration scrolls to highlight the code block labeled Legacy Code Example. This legacy sample reveals the more verbose, nested callback structure typical of pre-ES6 JavaScript. The viewer can contrast the complexity and readability with the earlier refactored code. Transitioning to the Advanced Patterns and Error Handling section, the demonstration explores further enhancements. In the default parallel mode, the Load Users button is clicked. Users are fetched in parallel, and as the operation progresses, a step log becomes visible, detailing each step and highlighting memoization hits for repeated requests. This illustrates how modern patterns can optimize both performance and resource usage. The demonstration then switches to the sequential strategy by selecting the corresponding radio button. Again, the Load Users button is clicked. This time, users are loaded one after another, demonstrating sequential asynchronous processing. The process is slower, but ensures order, and can accommodate rate limits or dependencies. Scrolling to the advanced code example, the demonstration presents code that implements these advanced strategies, including parallel and sequential async processing, error handling, and memoization. The viewer can study these patterns in action, solidifying their understanding of how arrow functions enable flexible, robust asynchronous workflows. Finally, the demonstration scrolls to the application footer, showing a link to the associated GitHub repository for further exploration. The experience concludes with a final pause, allowing viewers to reflect on the demonstrated concepts and outcomes. You've just seen how arrow functions can completely transform your JavaScript. turning tangled legacy callbacks into concise, modern async list processing that's easier to read, debug, and extend. By applying these patterns to your projects, you'll not only write cleaner code, but also boost your productivity and confidence in tackling complex asynchronous tasks. Start refactoring those old callback-heavy modules today, and you'll immediately notice reduced bugs, faster onboarding for teammates, and a smoother integration with frameworks like React or Vue. For even more actionable techniques and hands-on walkthroughs that directly apply to your daily development, subscribe now, because mastering these modern approaches is the fastest way to level up your front-end skills and stay ahead in today's evolving JavaScript ecosystem.